Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Thank you for joining us. We're quite pleased that we've got a nice full room of people. Let me introduce Michael. I'm sure that you know him already because he's very famous. But I met Michael several years ago, and I've always found him a particularly valuable resource because he's so thoughtful and so insightful, and he has such a clever way of kind of crunching down information and explaining it to us. So I'm particularly interested at the moment in incremental design and architecture and so on. And I saw Michael's presentation yesterday, which I thought was great, about data, the thing that DevOps forgot. I think I got that title slightly wrong, but nearly right.
Close enough.
Close enough, good. Which was a really interesting presentation. And one of the things that came out of that was, I think, that the data mesh solutions that you were talking about are very much in line with that kind of incremental approach to dealing with problems and trying to partition them and deal with them in different ways. Would you see it that way?
I do think so.
Yeah.
And I'll describe it in two different ways. One is we were just faced with a really large challenge, 300,000 data sets, unmanaged dependencies, and frankly, a team that would never finish cleaning it up because more people would be creating more dependencies faster than they could. And so there was a need to parallelize the work. But of course, if you're going to parallelize that work, it has to be possible for people to tackle small pieces in parallel, which means you need boundaries, you need tools, you need ways for them to see what they're doing and what the effect of what they're doing is. And of course, you're running a business, so you can't blow up your financial reporting to regulators overnight. That all has to keep working. That necessarily puts you into a mode of making incremental changes.
Yes. Yeah. So you're changing the wings on the 747 while in flight, kind of thing, but doing it safely, of course. So the other thing that is one of my areas of interest is that the principles of what I think of as software engineering, and in particular in this context, the principles of managing complexity, which I kind of list as modularity, cohesion, separation of concerns, abstraction, and managed coupling. And again, while you were giving your talk, I kept saying, he's talking about reducing coupling between those two parts. Mm-hmm. And this is about an abstraction. It's trying to define the separation between these different sets of data in a way, and an interaction point that's safe more safe to rely on with the data product owners and stuff like that. Do you think that's a reasonable approach? Do you think it's analogy, or do you think it's deeply true?
So I think modularity is certainly deeply true. That's a requirement. Mm-hmm. Ironically, abstraction in the data space is pretty limited. There is abstraction over the storage and the compute engines underneath it, but in terms of the semantics of the data being passed from one team to another, there's relatively little abstraction today, and from what I've seen, not great tools for expressing abstraction.
The thing that I was thinking when I was watching your presentation yesterday was, I think you were talking about having data product owners, and I took you to be saying that you would differentiate between kind of the external defensible sets of data you wanted to trust, and the kind of the internals. And
that part is very
models.
True. Yes.
And that was what I was thinking of as the equivalent of an API in data.
In fact, I'm definitely viewing them like APIs.
Yeah.
They are module boundaries.
Mm-hmm.
They're a place where you have a specified interface that someone can rely on and that you commit to keeping constant for some period of time. A lot of what we've been rolling out are what we call data domains, where it's domain in the same sense as domain-driven design. We're trying to identify what are the units of the business, not the org structure, but of the business, that will be relatively persistent over time, and that should be somewhat self-contained. In the transactional world, we're also looking at a lot of our microservices and saying we need some amount of additional structure there too. And we're also kind of converging on the domain concept. These are two worlds built by two different kinds of engineer. So it's a hypothesis that remains to be proven whether the domains in the transactional world and the domains in the data world align. I think if you were starting from scratch, you would draw the domain boundaries the same way. And then every domain has a composite interface of APIs, events in, events out, and data products in and data products out.
So how do you deal with that? In the microservices world, you normally talk about microservices being responsible for their own sets of data. So certainly the way that I've built those sorts of service-oriented systems before, we'd have a set of services that we were kind of watching streams of data elsewhere and archiving them in larger data sets to do the big data crunching and stuff like that. Is that the kind of approach you're taking, or are you doing something else? Are you sharing access to the data sets within the services? Or
So we're doing more of the latter. And I think actually a lot of companies end up doing that. The devs build their microservices, and then somebody comes along afterwards and goes, what about ETL? And now suddenly your private database is being consumed by something else that's now dependent on the schema. So sometimes the ownership of the data is a little bit of a polite fiction that actually gets broken pretty frequently. In our case, and this is a specialization at Nubank, I don't think this generalizes very well, but every microservice has its schema declared as data in the service definition. As it's deployed, that schema is used to automatically create ETL. So for us, ETL is not an opt-in. It is automatically done with all transactional services.
So the ETL is generated, and that's going to take it to some other data lake or data warehouse or something?
We do extraction from the operational databases through an ingestion process that takes it directly to Parquet files in S3. Now we're moving to Delta Lake in S3, and we're extracting the current schema, the data, and sometimes we're extracting all data, from day one. But increasingly, we're moving to incremental, where it's more like change data capture.
That sounds to me like a little bit at risk of having some fairly interesting coupling challenges between some of those different parts.
Indeed. And this is one of the things that's been a frustration for some of our engineers and that we're hoping to change in the future. The schema that microservice developers are writing is for transactions, right? It's the OLTP schema, which means it may include things that they don't really want published. And it may be in a structure that's not very convenient for analysis. Nevertheless, that's the first kind of raw layer. What we're looking at doing in the near future is adding the ability to do some modeling at that first layer and say what you're exposing is a source-aligned data product, which is your choice of how the entities and attributes should be represented. I think we will have machinery that gives you the identity mapping as a default. So again, you don't have to opt in. You're automatically having your data published. But if you want to have control over how it's presented, then you can.
So if you wanted to exert that control, you could do that thing that we were talking about of essentially making sure that the stuff that you were extracting was an appropriately safe part of the contract that you're willing to defend going forwards.
Yeah, exactly. A challenge that we are seeing with that is the devs who are building the microservices aren't always that fluent with how the ETL processing is going to go. So they may not be representing things in an efficient way. They may not have the kind of partitioning that would be useful for downstream processing. And so we're definitely going to have to kind of bring these two worlds back together. So today you could think about it as saying there's the operational world, which is divided into microservices. There's the analytical world, which is divided into data sets. And what we're trying to do is create domains and merge them together within domains and have them communicating and working together.
So I'm going to ask you my trick question now. So how independently deployable are your microservices?
Very.
Very.
Yep.
So they are. You can deploy those without testing them in the interactions with other services and so on.
Well, I mean, there's always some integration testing, and we have sandboxes.
Okay.
Nubank started 12 years ago-ish, and really started from a blank slate. And so it was all built with microservices and continuous delivery from day one.
Cool. I'm very pleased to hear it. There's a nice book that you can buy downstairs. So this is a big problem, and data is different to think about. And I know I keep pushing my own ideas, I'm sorry. The reason why I was kind of particularly interested in asking that question about the modularity, cohesion, separation of concerns and so on, is that I see those as fundamental tools, whatever the nature of the information products that we're dealing with. It seems to me that those ideas are quite profoundly applicable at every level. I suppose I was testing my theory. What's going through my head as you're talking about those problems? So how could I increase the separation of concerns? What could I do to abstract that so that it represents a safe, defensible API? And all those kinds of things. I don't know whether I have a question now, but I'm just trying to defend why I was going down that route, I suppose.
Well, we need to think about the data world at two different levels simultaneously.
Yeah.
At one level, we're talking about the machinery and the plumbing. So we're scheduling jobs, we're managing storage, we're moving bytes around.
Yeah.
And for building that platform, all of those principles apply.
Yeah.
It's software engineering for managing data.
Yeah.
At the level of the data itself, we also need to apply modularity. We need to worry about coupling.
Yeah.
There's less separation of concerns than maybe we would like. Maybe we just haven't figured out what those concerns are and how to separate them.
Yeah. That's a bit of a trickier thing, I suppose, with
a little bit trickier
with data. But
but cohesion is certainly a real factor that we have to think about.
Yeah.
Operating at both of those levels simultaneously gets a little bit brain bending.
Yeah.
We often partition those responsibilities to different sets of people, but there's kind of feedback and feed forward.
Yeah.
The people building the plumbing and the machinery may do things that make it conducive to process your data in a particular way.
Yeah.
More partitions is better if you tune it this way. Fewer partitions is better if you tune it that way.
Yeah.
And then the things that people are doing in the layer of the data itself can certainly affect how well the platform is working.
Yeah.
Often these are different groups of people out of necessity, but they have a deep influence on each other.
You mentioned the word platform there in terms of the way and that kind of starts my head going in another direction, thinking in terms of platform engineering and how we do that. That for me is a kind of loaded term, and I get a bit angsty about it because I think it's often done very poorly. I think it's often treated as an excuse for just allowing other people to worry about how you talk to the cloud or something like that. Platform engineering for me seems deeper in terms of the design of a system to try and help us to manage things. And I was wondering your thoughts about that. So, for example, you were talking about, while you were describing your microservices, talking to the data and wanting to be able to define which bits of the data you needed to be extracted and be part of the publicly available information and which parts not. I was thinking, I wonder if that's a job for a platform of some kind that you could kind of describe to help your programmers do that more easily.
Yeah, certainly. I've also become a little wary of the word platform because it's gotten so much cachet and so much momentum that everything becomes a platform.
Yeah.
But actually, when you look at a lot of these things, they look more like complex subsystems than platforms.
Yes.
In trying to get more real platform engineering and move from the complex subsystem to something more self-service, we've brought in a few things that would be maybe a little unusual. I'm in the global platforms building block, dealing with data platforms. So almost as far down in the stack as you can get. The Kubernetes guys and the Kafka guys are one level deeper. But I have product managers who do voice of the customer reports on a quarterly basis. The customers are internal customers, but we're applying the same methods and techniques as you would for external customers. And we're really trying to make sure that the platform embodies principles that you would recognize as something you could put out there in the world. So, for instance, you should not be able to overconsume resources to the point where you're denying service to everybody else. You should have the ability to know what your changes are going to do to you, but you should have the confidence that your changes are not going to hurt everybody else.
Yeah.
That has not always been true, but we're trying to make it true. The other thing about a platform is that you should see a lot less backlog coupling across teams than with a complex subsystem. So we do need to deliver features, but we should be delivering features that others can pick up and use when they need it. It should not be the case that in order for one of the product teams to meet their current iteration date, we have to deliver something on their backlog, on their schedule.
Another of your talks, which I've loved and quoted many times over the years, we were at a conference together and I saw you do a talk about coupling. And you talked about different types of coupling, and that's the model that I use, and I call it the Nygard model of coupling. It's worth looking up. It's a really good
I just want to be on the record. I didn't name it after myself.
I named it. One of those types of coupling is developmental coupling, and that's a particular problem with platforms, it seems to me, because they are often an intense source of developmental coupling. The idea of developmental coupling is you've got two services, A and B, sharing a platform. A wants a change, and now B is forced to change as a result of the change that A wanted. Is a fair description?
Yeah, and especially when you look at an organization that scales, if you have development coupling as a common practice, that's kind of an n-squared problem as the org gets bigger and you have more teams, and you reach a point where everybody's spending half their capacity just responding to changes that others are making instead of actually advancing your business forward.
Yeah. Could you talk a little bit about some of the ways in which a good platform would help us to avoid those kinds of problems?
There's something that I haven't yet been able to articulate super well. And we'll see if it comes out of my mouth better this time. Maybe you'll help me figure this out and name it. The deeper you are in a stack, the more ripple effect your changes can have, right? Because you have more inbound dependencies. And so you need your interfaces to be more stable. And if it's going to be more stable and also work for many different use cases, it has to be expressed in a somewhat more abstract way, like one notch more abstract, if you can picture some kind of a ladder of abstraction. So that is one of the key techniques, is you're defining that abstraction of the operation rather than just exposing the raw functionality of the services of your platform. In fact, we've had sufficient difficulty with the term service that one of the principal engineers on my team created this neologism of a plank. And I forget what the acronym expands to, but it's essentially the stable part of the API.
Yeah.
Because people were very comfortable writing a new service and inventing a completely new API for the new service. Yeah. And so there's no easy stepping stone from old to new. So here the idea is the plank is just the portion that's not administrative, it's not health checking, it's just the operations you want. And it's a somewhat abstract representation of those operations.
Yeah, I think that's a key idea. And the other part of that, in terms of the abstraction, you need to be thinking about the next layer down of detail to be able to achieve that abstraction. And the next layer up to it, you need to understand the problem that you're trying to solve from the usage point of view, it seems to me, to be able to get a sensible abstraction that's going to serve that use. And the next layer down, so you can, as far as you can, attempt to at least mitigate the leakiness of the abstraction.
Yes, exactly. I mean, there are some techniques that you can use during design to help make sure that you do that.
Yeah.
One that I continually challenge people on is you're designing this interaction. How would this work if there were 20 of the consumer?
Yeah.
How would it work if there were 20 of the provider? Is it an interface definition that still makes sense when I talk about new consumers that haven't been conceived yet, or may try to use just this piece of your platform and not that piece of your platform?
Yeah.
That's kind of an older reference now, but Baldwin and Clark have this book, Design Rules, that talks about this set of transformations to see if you've got actual module boundaries. Can you augment? Can you interpose? Can you split? Can you join? This sort of thing. And looking at your APIs that way and saying, does it make sense to use this piece in isolation, or split it, or put an intermediary in? These are ways of testing your interface design before building it.
Yeah, I've come to a realization, an insight about my own way of thinking about some of these things. A lot of the way that I think about these things is to be outcome focused rather than implementation focused.
For sure. That
seems really important. So looking at things always from the perspective of usage. One of the things that drives me nuts is that I think user stories are a really good idea, but they're really often naively interpreted. People assume that when you say user, so I'm writing the back end of a system. Have I got to be thinking about some person on a website for the user stories? No, because if you're writing a back end system, your user's the next layer up. It seems to me that that's much more about separating what the system needs to do from how it does it, and that's a really valuable separation. And the user stories is kind of a shorthand for that, really.
Yeah, I often talk about this as outside-in design versus inside-out. What is the interface your caller would most like to use?
Yes.
Even if that's not easily provided by one service or the machinery you've got.
Yeah.
Kind of design around that. But also at the same time, sometimes the ideal thing that a user would want to call is sort of the do what I mean packet.
Yeah.
And you can't necessarily go all the way in that direction because at some point, the do what I mean needs to be split into a couple of things that might be used separately and composed in some cases, but not in others.
The reason that thought occurred to me is that the example that you gave of the book where it's identifying these different types of properties of a modular interface, it reminded me of that, because if from a usage point of view I can add this new behavior on by augmenting what's already there and that kind of thing, that sounded very similar because it's thinking about that outside-in kind of perspective.
Yeah, I think so.
There's lots of different ways of talking about the same ideas, it seems.
Yes, and this is one of those places where we don't always have the right vocabulary, and you get into I know it when I see it territory.
Yeah.
At one point we've talked about David Deutsch and some of his works.
Yes.
He talks about this leap to universality when you go from pictograms to an alphabetic language.
Yes.
Well, there is the same kind of thing that happens with interfaces. You can get to the point where you're redefining SQL, and now your interface is one method, but it's embedding a language that's universal by itself. And you've gone too far at that point because you've reintroduced complexity to somebody else.
Yes, exactly.
So you go a little more abstract, but not all the way to that universality.
Such a common anti-pattern. It seems to me that every one of those boundaries should always be hiding some information of some kind, really. So not just exposing the outside world. The David Deutsch book is perhaps the most mind-bending book that I've ever read, and I recommended it to Michael a long time ago. It's called The Beginnings of Infinity. He's a research physicist, and it's a really deep book. It took me months and months to read, but I would recommend it to you if you're nerdy enough. We both enjoyed it.
I found it enlightening, and I keep thinking about it years after reading it.
I think it's quite deep in terms of describing the philosophy of science, and one of the ideas that he talks about that certainly I like very much is the idea of good explanations for things. He part of his argument is that science and knowledge doesn't proceed just by experiment. It also proceeds, and more often, ideas are ruled out because the explanations aren't good. Ruling out by experiment is best, but you can also rule out by coming up with better explanations for things.
I think we do this a lot when we are debugging or diagnosing systems. You'll have an anomalous behavior. Maybe it's a complete failure, or maybe it's just weird results sometimes. And there's always the multitude of possible causes. And you're sort of running a search to try and find questions that help you partition the possible causes into still possible and ruled out. And you're trying to get to what is a good explanation for why this behavior would be occurring.
Yes. I think I can give good explanations for why continuous integration is better than feature branching, or why test-driven development is better than not, and so on. Also, going back, I was going to mention test-driven development before, when you were talking about the importance of creating interfaces that make sense and are easy to use, and the importance of test-driven development in that, because you're the first user of the interface when you write the test against it.
Yes, if. This is something you probably do instinctually because you've been doing it so long, but when you're the one both designing the interface and calling it, you have to create in yourself a kind of willful amnesia at times.
Absolutely.
And step back and say, I'm going to temporarily forget everything I know about the inside of this.
Yeah.
And then still have it somewhere that you can page it back into main memory when you need it again.
Yeah.
But I find that act of willful amnesia to be pretty important in systems design writ large.
Yes.
Not just TDD, but
anytime
you're talking about calls between components or messages between systems. I need to temporarily forget that I know all of this about
Yeah.
my internal state machines and codings and so on. Prior to Nubank, I was at Sabre for 3 years. Sabre was one of the first electronic booking systems, maybe the first, I think.
Yeah.
And talk about leaky abstractions. I learned that the reason you can't book a flight more than 364 days into the future is because the database record, called the PNR, didn't have a year on the date. It just had month and day. And then that PNR turned into a wire format that turned into an industry standard that is now hardwired into ticket printers in airports all over the globe. So very, very hard to change.
Yeah.
There's a similar story about why there are exactly 26 classes of seats. Again, these very leaky abstractions, because that notion of the willful amnesia didn't exist.
I've seen completely analogous things in my career. It seems a function of sort of really old technologies where storage was so
Precious.
high cost that you really managed it to the bit.
Yeah.
And then translate into modern systems, the choices make no sense. Once worked close to a team that were revamping a configuration management system for cars for one of the big auto manufacturers. They had a car configuration code that was based on some ancient COBOL system and punched cards and so on. And that had become so complicated over the years that they'd started reusing all of the bits in this thing. And essentially they'd invented this horrendously complicated Lempel-Ziff style algorithm to crunch down data into this.
So you have one character string that tells you everything about the car.
You have one character string, and if these two bits were set this way, then those two bits meant the colour, and if it was set the other way, they meant whether it's got front doors or not. It was just absolutely insane. But we were writing a Java system that had to interpret that and keep those codes coherent.
There's some reason to believe that the genetic code for development of organisms works the same way. That
absolutely.
These genes activate or deactivate or change the interpretation or suppress that.
We used to write assembler for a living. I used to play with self-rewriting code just for a laugh. We were talking in the break before we started this. We were riffing on where we see the industry a little bit, the state of the evolution of our practice.
Mm-hmm.
Where do you think we are?
Well, internally, I have a cynic and I have an optimist. And some people say a cynic is just a disappointed optimist or frustrated optimist. I think we've made advances since I started doing this 30-some years ago. Unit testing, for me, was a huge advance in industry practice, and it made a big difference to the quality of the systems we create. I think that that's now pretty much universally accepted. Version control, universally accepted, was not widely used when I started. I remember SneakerNet and putting code on floppies and having one person load all the code and run the build on their machine. So I think we've made advances in these practices. At the same time, we've constantly got a new crop of people coming into the industry who need to learn how things are done.
Yeah.
And for them, the bar for what we would consider competence keeps getting higher and higher and higher. So now an entry-level developer is not just worried about the IDE on their machine. They have to know about build systems and package managers and lock files. A lot of complexity in the environment that didn't exist. So I kind of feel like we are constantly making advances, but every time we do, like the improvement in quality gets eaten up by increases in complexity and scale of the problems that we're trying to solve. And maybe we're just unlocking levels that enable new scale, or maybe we're just barely staying ahead of being swamped by complexity. Depending on how much sleep I've had on a given day, I'll go one way or the other.
Depends whether it's the optimist or the pessimist talking.
Yep.
That's an interesting thought. I confess my grumpy old mannishness, the pessimist in me, thinks that there are ways in which we make it more complex for ourselves to no benefit. I did a little exercise when I was writing my engineering book in which I wrote a simple CRUD web app, and I wrote one of them in what was the most popular kind of web toolkit, Angular and stuff and all of that. And I wrote exactly the same app in the technology of 1996, sort of JavaScript.
CGI
scripts, that kind of stuff. And it was functionally the same thing. And there was it took me maybe just because my skills weren't very good in Angular, but it took me about half the time to do the 1996 version, and there was about a quarter of the code.
I totally believe that, but I also believe what you're seeing there is the floor is lower. In other words, the minimum requirement to get that working is lower, but the limits of how far you can go with that kind of interface is also lower.
Yeah.
So you wouldn't be able to serve web plus mobile plus
and it's not a fair
geolocation.
comparison. Martin, I told Martin Fowler this story once, and he pointed out that the Angular version would have worked on all of the browsers, and it would have looked after a whole raft of other problems.
Exactly.
Which is fair enough, but we don't always seem to be making the progress that we think we are making with some of the changes that we're making. And
there's a phenomenon I wrote about one time that I call complexity collapse, where a new way of doing things is introduced. I like to use Java Spring as an example. There was a time when Java Spring was incredibly simple. It was so much easier than the thing it was disrupting. But over time, it accretes more and more stuff until eventually you reach a point where the tension gets too high and there's some new unforeseen requirement and something else comes from outside and disrupts that.
Yeah.
But it also kind of starts the cycle over again. We had XML show up, and that was easier than the binary RPC formats that we had before that. But then you add in XML schemas and namespaces and WS star standards, and it gets so we bring in JSON.
Yeah.
And now we've got JSON schema and JSON web tokens. And
that's what happens when you become a grumpy old man.
I also talk about the big cycles of swinging from RPC to event-driven and back to RPC, back to event-driven. We're currently on a very event-driven sort of space, but I expect somebody's going to invent a new technology that if you squint, it's really going to be RPC. But it's going to look really simple for a while.
Yeah, I think so. Okay, thank you very much indeed. Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.